We're going to look at the following example. NBA player Stephen Curry has made 44% of his three-point shots during his career. In a game in which he shoots 12 3-points, find the probability that he makes. And then there are several questions. So the first one is exactly 5, then we'll have at most 2, at least 3, and so on and so forth. Okay. First, let's confirm that this is the binomial experiment. And right here, we're going to try to describe that. So if it's a binomial experiment, then there should be only 2 possible outcomes. So in this experiment, Stephen Curry has to shoot 3 points, right? So what are the outcomes of every shot? Well, there are only 2 outcomes. Either he makes a 3-point shot or he doesn't make. So those are 2 possible outcomes every time that he shoots a 3-point, right? So miss or make. The 2 possible outcomes of the binomial experiment are called success and failure. Which outcome in this case is referred to as success? Now, we have to keep in mind that success doesn't always mean something positive, but success is going to be something that we're counting. Let's go back and read the question. So the question was, in a game in which he shoots 12 3-points, find the probability that he makes exactly 5, that he makes at most 2, and so on and so forth. So looks like we're going to have to find probability for certain number of 3 points that he makes, right? So since this is what we're counting, the outcome that we're going to call success is that he makes a 3-point shot. He makes a 3-point shot. Next, we need to remember that binomial experiment consists of a series of trials, or we can call them mini experiments. So what is the number of trials here? Well, if it says that in the game he's going to shoot 12 3-points, that's what we're going to consider trials, right? So the number of trials is 12. He's going to shoot 12 times. Next, we need to make sure that probability of success is the same for each trial. So, in other words, probability of success does not change from trial to trial. So it means that every time Stephen Curry shoots a ball, probability that he's going to make a 3-point shot is the same. Well, that's the case in this situation, but what is that probability? What is probability of success in each trial? Well, that is his historical percentage of success. So it says that he has made 44% of his 3-point shots. So among all 3-point shots that he attempted, he made 44%. And that's going to be a probability of success for each trial in this case. Of course, percentage we have to convert to a decimal, so that's going to be 0.44. Finally, to verify all conditions for the binomial experiment, we have to point out that in this situation, trials are independent of each other, right? So the outcome of one trial is not going to affect the outcome of the other trial. So we're dealing with the binomial experiment. To compute probabilities of binomial experiment, we're going to use calculator. There are 2 functions that we have to use. And to find those functions, we need to do the following steps. First, we have to press second, then vars. As you can see, above vars it says distr for distributions. And as you remember, we're working with binomial distribution, so it's going to be somewhere on that list. So to find it, we have to scroll down until we reach A, line A. See how it says Binomcdf? So this is binomial probability distribution function. And if you scroll one more, it's going to be Binomcdf. We will be using both of them, but it all is going to depend on what kind of question we're being asked. So let's first write down steps that we just did to find those 2 functions, and then we're going to talk about which one we're going to use for the first question. So calculator steps. second, then you press on vars, or the button that says vars, and then scroll down to line A, Binomcdf. Well, and B is Binomcdf, but actually for the first question, we'll need Binomcdf. What is the first question? The first question is the following. In a game in which he shoots 12 3-points, find the probability that he makes exactly 5. So word exactly is the key word. I'm going to underline it, exactly. So when we need to find probability of the exact number of successes, right? Because he makes 5, it means that there are 5 successes out of 12. Well, when we need to find the exact number of successes, we're going to use Binomcdf function. So the difference between the names of those two, it's PDF versus CDF. So we always have to pay attention to this letter. Now, PDF, use for the exact number of successes. Okay, so how do we use this function? Let's go back to the calculator. Here it is. Now I'm gonna go back or go up to A, Binomcdf, and I'm gonna press enter. As I press enter on my calculator, I can see a couple lines here, right? So let's read them. The first one says trials, then it says P, then it says X value. Well, let's talk about each. Now, trials. Our calculator is basically right here is asking us to describe the binomial experiment. We already described it over here, but our calculator needs that information. So let's put it in our calculator. So trials. Calculator is asking how many trials we have on this experiment. And we already talked about how it's 12 trials because Stephen Curry has to shoot 12 3-points in that experiment. So the number of trials is 12. Now, P. P stands for probability of success in each trial, and that's 0.44 from the given 44%, his historical success with 3-point shots, right? So P stands for probability of success in each trial, and it's 0.44 in this case. And now X value is the number of desired successes. Remember, we're trying to calculate probability that he's going to make exactly 5 3-point shots. So that's the desired number of successes, and that's what X value is, 5. And once we enter all those values in the calculator and then press enter 2 times, no, actually it's 3 times, right here, we're going to get that probability. So see how it's easy with the calculator, it right away gives us the probability, and that's the answer. Let's make a few notes, and then I also have a comment. In the case if your calculator is slightly different and it didn't show you that little menu. Now this is what I saw on the calculator. First it's asked for trials, and we entered 12. Then it said P, that's probability of success in each trial, it's 0.44. And X value is 5, number of successes. Number of successes. Okay, and then calculator provide us with probability. I'm going to use probability notation to write down the answer. So probability that he makes exactly 5 3-point shots is, and I will round to 3 decimal places, 0.226, right? 0.226, which is approximately, if I convert it to percentage, it's approximately 23% chance that out of the 12 shots, he's going to make exactly 5. that's exactly 5. Okay, so that's the answer. Now I was gonna make a comment here. So if your calculator didn't offer you to enter numbers this way, then you have to enter those same numbers but in order. So on your calculator, if you didn't see that screen, it means that what you saw was the following. You saw Binomcdf with parentheses open. So what you need to do inside those parentheses, you have to type those 3 same numbers in that same order, separated by commas. See, I actually have that here. Okay, so Binomcdf, it didn't fit in the screen, but if I scroll to the left, okay, so Binomcdf, then you have parentheses open, and then you type 12, comma, 0.44, comma, 5. So you have, and then you close the parentheses and you press enter, and that's how you'll get the answer. You just have to remember the order. So first is the number of trials, next is the probability of success in each trial, and then the number of exact number of successes. So this is how you use calculator to answer the first question, exactly 5. Let's answer the second question. In the second question, we have to find probability that he makes at most 2. Now, what is at most 2? So at most 2, we can rephrase and say it's up to 2, right? So I can write it this way. What's the probability that he makes either 0 3-point shots, or 1, or 2, right? That's same as at most 2, or it's like up to 2. How do we calculate this probability? Well, one way is to think that probability of 0 or 1 or 2 successes can be calculated this way using the addition formula. I can find probability of Stephen Curry making 0 shots plus probability of him making 1 3-point shot, and plus probability of him making 2 shots. And I know how to find each, right? We can use Binomcdf to find each, exactly 0, exactly 1, exactly 2, and add all those probabilities. But there's actually a quicker way, and that quicker way is to use the second function. Remember the one we saw on the calculator? That's the one that's called Binomcdf. So we're gonna use Binomcdf because this function that has c instead of p, it's called cumulative distribution function. So it actually calculates probability up to a certain number of successes. So calculates probability up to, and these are the keywords here. I'm going to be referring to them several times. Up to a number of successes, which is exactly what we need to do right now, right? We need to do it up to 2. And as we use this function Binomcdf, we just have to use it once. We don't have to add anything. It will do all the work for us. So let's go back to the calculator. So I'll go back to second vars, so the distributions, scroll down, but this time scroll down to B, Binomcdf. I'm going to press enter. And as I can see here, those items are the same, right? That little menu looks exactly the same. Trials, P, X value. So the meaning of the first 2 is exactly the same. Trials, how many trials do I have in the experiment? Well, still 12. Probability of success in each trial is still 0.44. But the X value, it has different meaning when we use Binomcdf. It has this up to a number of successes value. So here it's at most 2, meaning it's up to 2 successes. Well, that's what I'm going to put here. Before it was exactly 2. If it was Binomcdf, now it's up to 2. So that's the meaning of this number. So I'm going to use Binomcdf this way. That's how I enter it in the calculator. I'm going to press enter in a second, but I just want to list those numbers here. And again, if your calculator is not showing you that little menu, then you'll have to enter numbers this way. So that's what you'll see on the screen. Binomcdf with parentheses open. So it's ready for you to enter the numbers. You will enter 12, put comma, then enter 0.44, comma, and then put right down 2. Close the parentheses and then press enter. I'm pressing enter. And we get 0.04867 and so on and so forth. So if I'm rounding to 3 decimal places, it's going to be 0.049, 0.049, which is approximately 5%, right? 4.9 or approximately 5%. As you can see that the chance of for Stefan Curry to make at most 2 3-point shots, which is either 0 or 1 or 2, is not that high. It's a pretty small chance. Well, because he's a good player, right? So it's kind of like hard for him to miss so many 3 points. So that's how we find probability in this case using Binomcdf function. Next, let's try to look at how we can find probability that he makes at least 3 3-point shots. At least 3. Now, what does it mean at least 3? It means that he makes either 3 or 4 or 5 or 6 and so on and so forth up to, we know that he's going to shoot 12 times in total, right? So up to 12 or 12. So how do we find this probability? First option is to find each individual probability, chance for him making exactly 3, exactly 4, exactly 5, exactly 6, up to 12, and add those probabilities together. And that's where we would use Binomcdf, right, for finding exact probabilities of each case and adding probabilities together. But it's kind of like a lot of work. Let's see if we can use Binomcdf, right, because it's cumulative distribution function. Well, we have to remember that Binomcdf is being used to find number of successes up to a certain amount or certain number. And that's not the case here. It's not up to a certain number here, but 3 and more, kind of like on the other end, right, on the other side of that. But we can actually apply complement rule in this case. So remember, the complement rule works like this. Well, to find probability of certain event, you can always take 1 and subtract probability of its complement. So what is the complement? What kind of event is the complement of the one that we're looking at? Well, complement always includes outcomes that are not included in the original event. So we have to include all outcomes that are not listed here. What are those outcomes? Well, it's either 0 or 1 or 2. 0 or 1 or 2. And when we write it this way, we can now see that well, first of all, it's a complement. Let me make a note. That's the complement. But besides the fact that it's a complement, I can also rephrase it and say it's the same as up to 2 successes, right? And when we say up to 2 successes, it means that we're allowed to use Binomcdf function. Up to 2. Now, we kind of got lucky here because we already know what that probability is. We found it in the previous question, right? We already have the number. But even if we didn't have that number, probability, we would be able to find this probability quickly using Binomcdf function. If it was 0 or 1 or 2 or 3 or 5, let's say, then we would do Binomcdf with 5 being entered for the x value. Now this time we can simply take 1 and subtract probability that we found in question B. And that is 0.951 or approximately 95% chance. So it's very likely that he's going to make at least 3 3-point shots. So that's the way to calculate this kind of probability. And finally, our last question here is to find probability that he makes between 4 and 8 shots inclusive. So let's write it down using notation. So probability between 4 and 8. So that's how it's given to us. But let's expand it. Let's kind of like list all the possible cases that are included in here. Inclusive meaning including 4 and 8, including those two cases. So it means that we want to find probability that he either gonna shoot or make 4 3-point shots, or 5, or 6, or 7, or 8. So that's the list of the desired outcomes. Let's think how we calculate this probability. Once again, one of the options that we always have is to find probability for him shooting exactly 4 using Binomcdf, exactly 5, again Binomcdf, and so on and so forth. So exact number of successes for each, and then just adding up those probabilities. That's one way. But is there a way to do it quicker or find it quicker? Well, yeah, there's actually a way. Now, if we think about another function, Binomcdf, remember how it's being used for finding probabilities up to a number of successes. And that's not the case here, right? We can't say it's up to 8, because up to 8 includes more than we need here. Up to 8 includes everything from 0 to 8. But you know what? We actually can start like that. So let's start making notes. What if I find Binomcdf for up to 8? So I'll have to enter 12 in my calculator, 0.44. Remember those three numbers we always enter in order. And then the last one will be 8. Well, that means that this probability, or this function, will calculate as probability for him making up to 8. Up to 8 successes. But what does it mean up to 8? Well, it means that it's either 0 or 1 or 2 or 3 up to 8. Now, this is more cases than we need, right? Which ones we don't want to be included? Well, if it's from 4 to 8, it means that those 4 at the beginning, 0 or 1 or 2 or 3, we don't want to have included, right? So it has more cases than we need. Well, let's try this. We're going to find probability of him making up to 8 successes or 3-point shots, but then we're going to subtract probability of him making up to 3. So I want to exclude those cases, 0 or 1 or 2 or 3. But another way I can say what those cases are, it means that that's the case when he makes up to 3-point shots, right? Up to 3 successes. How do we find probability of up to 3 successes? Well, that's by using Binomcdf. Binomcdf, it's going to be 12 trials, 0.44, probability of success in each trial. And this time we're going to put 3 over here. The meaning of this number will be up to 3 successes, which is 0 or 1 or 2 or 3. But because we're subtracting here, it means that we're excluding that from the first probability. So what's going to be the answer? By the way, we can enter this entire expression in our calculator. Another option, of course, is to calculate this probability and then the second one and subtract them, but I'll show you how to enter it all at once. That's basically, well, as I just said, just entering it. So we start by, let me turn this on. We start by Binomcdf. Second, vars, scroll down to B, which is Binomcdf. Press enter and then enter 12.44, or use that, separate them by commas if you have slightly different calculator. Then x value here will be 8, right? So in this case, 8. So I'm going to press enter. So now on my calculator, I can see that it says Binomcdf with those 3 values entered. So I just entered this part. But what I can do next, I can put minus. I can continue typing. I can say minus, so I'm pressing right here, minus, minus. And now I'll have to do Binomcdf with 3 at the end. So I'm doing second vars, scroll down to Binomcdf, enter, and change 8 to 3. Press enter. Here it is, that second Binomcdf. Now the beginning of that expression is to the left. I just cannot see it. It didn't fit in that line. So what's left to do is just to press enter. And here's the result. That's the probability. 0.819. 0.819. I don't really have much space here, but I think I can squeeze it in. 0.819, which is approximately 82% chance. So it's an 82% chance that Stephen Curry, if he shoots 12 3-point shots, he's gonna make between 4 and 8. So that was the example for computing binomial probabilities using calculator and 2 functions, Binomcdf and Binomcdf.